Okay. Kevin Elder talked about the issue with nutrient management, and this relates a little bit to that. We did a study, completed the 4th year in 2012, looking at alfalfa in response to sulfur, gypsum, and various rates of P and K. Our fertilizer prices are increasing, so what impact will it have on alfalfa if we reduce our rates, and also in view of the nutrient management issues that we're running into Ohio? Sulfur input sources have been changing in crop production. I'll describe some of those. Should we begin to start keeping an eye on sulfur content in our alfalfa crop? And there have been recent reports about the benefits of gypsum and other flue gas desulfurization byproducts on crops. And does alfalfa respond to those? Now, just a quick point about sulfur. It's an essential macronutrient for plant growth. Plants can't grow without it. It's important in several amino acids and protein enzymes that regulate photosynthesis and nitrogen fixation. So sulfur is important for yield because it affects photosynthesis, and protein content because it affects nitrogen fixation. It's also, so there's some amino acids that it's a constituent of. One of them is an essential amino acid for cattle. Now, historically, we've not needed to apply sulfur. We have not had sulfur deficiencies in our soils. We've had plenty of sulfur. This is a direct quote from our Tri-State Fertilizer Bulletin recommendations. And it basically says sulfur fertilization is a rare need. But, okay, last point, because it affects nitrogen fixation, the deficiency looks like a nitrogen deficiency. Kind of pale green color, overall light green, spindly stems, and weak growth. Now, sulfur cycle. Here's the soil solution, like Kevin showed, that is available in the sulfate form for plant uptake. Sources into the soil are from organic sources, manure. If you have manured fields or in your pastures, it is unlikely that you're going to have a sulfur deficiency. Also, residues from plants add sulfur to the soil. Historically now, probably a very important source of sulfur in our soils is from burning our high sulfur content coal and the pollution in the air, the acid rain, putting the sulfur back into the soil through the rain. Now, we've been doing a good job of cleaning up our smokestacks, and this source is really declining, okay? Now I'm going to show you how much it's been declining. So don't blink or you'll miss this. This is running 3-year averages starting from 1984 to 86, and then every 3 years running, okay? And we're going to end up in 2008, I believe. Okay, here we go. So heavy concentrations here in the northeast part of the country. That's where we are, 2007 to 2009. Pretty dramatic change. Okay, 40% less deposition from the air in Ohio. 31% lower nationally. Okay, so our Clean Air Act is doing its job. 31% reduction nationally, 40% reduction in Ohio. The other place where we're not getting sulfur is our fertilizers are a lot cleaner than they used to be. A lot of the fertilizers we're using nowadays contain no sulfur that come along with the P and K. We have higher crop yields removing more sulfur, especially our grain crops. We don't really use sulfur-containing pesticides like copper sulfate much anymore. That used to be used for fungicide treatment. Now, in grain crops, they have better fungicides that are being used. And we have a lot less manure on most of our land because we have less animals. So all these things reduce sulfur. So the objective of this study was to compare alfalfa response to elemental sulfur, gypsum, and reduced rates of P and K. Our treatments were, okay, we didn't put on any fertilizer. That was one control. Our other control was our normal phosphorus and potassium recommendation based on the soil test that we started with. Then we did crop removal. Kevin Elder talked about that. So we based our crop yield. We were very hopeful, and we said we're going to get 8 tons of alfalfa, and that's what we based our crop removal on. And then half of that, and then we added the tri-state normal recommendation plus gypsum and the tri-state plus elemental sulfur, okay, for P and K. This is what we actually applied in those treatments. Tri-state called for 125 of phosphorus in the pre-plant and 195 pounds per acre every year after that. And the reason is, I'll show you in a minute, that was a 7 part per million phosphorus soil. I don't know how we found that out at our experimental station, but we did. 190 pounds of K2O the first year, 300 in maintenance. And this is the top cutoff point for our tri-state recommendations. Crop removal is 400, okay, because 8 tons times 50 pounds per ton crop removed, that's 400. Okay, so this is probably closer to what we should have been putting on. Our tri-state usually has crop removal plus buildup if the soil is low. If it's not low, then it actually is less than crop removal. Okay, our recommendations. 50% crop removal. You can see there we're putting on quite a bit less fertilizer overall. And this is just the gypsum, and this is a sulfur from the gypsum, which was 17.7% sulfur. And we were applying about a 3/4 ton of gypsum on the surface every year. And that's more than you need to, but kind of looking at it as a disposal source and just kind of pushing the envelope there. So a lot of sulfur. And then the elemental sulfur treatment, we only put down 75 pounds incorporated pre-plant and never put on sulfur again. Okay? And this should really, based on the studies I found in Wisconsin and other places, this is kind of the rate they would say would carry you for 3 or 4 years. Put it on once, and that is what is all you needed for 3 or 4 years. Okay, so here's the total pounds per acre we applied in each treatment. And I'll show you the cost later. Okay, so significantly less at the 50% rate. All right. I'm going to keep moving. Here we're putting on quite a bit less phosphorus in the crop removal rate and the half crop removal rate than what was recommended, because this recommended amount includes quite a bit of buildup because we were so low in phosphorus. Okay? Now, here's our soil test that we started out with. 1.7% organic matter, great pH, 7.5 parts per million phosphorus. 25 is the critical point. Above 20, you should be, like Kevin said, 25 to 40 or 50 for alfalfa. We're down to 7. This is probably a lot of these soils like this in eastern Ohio too. 83 parts per million potash. This is slightly below the critical point also, below which you expect yield loss. So we really did need to put on potassium. And the sulfur soil test isn't very reliable. You should use a tissue test, but we tested it anyway, 8.2. So then in November 2011, we didn't get the 2012 results back yet. We were a little slow sending the samples in. But here's what you can see. No significant change in pH overall. A couple treatments did drop some. Phosphorus, you can see here, we actually went down where we were putting on crop removal and half crop removal certainly, and we built up where we put on the recommended amount. Okay? We built up a little bit. Yeah, this is saving Lake Erie here. Okay. Then the sulfur, you can see the two treatments that had sulfur in them, the soil test for sulfur went up quite a bit too compared to the other treatments. Okay? So I wanted to show you that before I show you any yield. Here's the first year of the seeding year. Oh, we really did need fertilizer. Only a little over a ton with none. The recommended rate, we got twice that. And then the two treatments with sulfur were no different. Starting to get a little bump here with gypsum. Okay, the P and K removal and the half removal were lower than our recommended. This is the average for the next 3 years on an annual basis. So we were shooting for 8 tons. We got 6 with our recommended. Again, no fertilizer, the lowest. The two highest were the treatments that contained sulfur, and the elemental sulfur being the highest, 11% more than the recommended rate. Okay? And here we're getting lower yields with our crop removal, even though we're putting on more potassium here than the recommended treatment, but a lot less phosphorus. So you got to have a balanced program. And this one we're losing 0.5 ton per year compared to our recommended. Okay, but we're spending a lot less on fertilizer. So here's the grand total for the 4 years. Overall, about a 9% bump from the highest treatment to the recommended rate. And pretty much follows the same pattern you saw before. But again, we did get that bump. This is a total tonnage over the 4 years with some sulfur. Now, here's our fertilizer cost. This is the cost of fertilizer in today's dollars. This was in what our budgets show for this year, minus an application cost of $6 an acre. And just one application per year. Pretty significant difference, especially here. But remember, we had lower yield, so can we get by with it? So here's the total dollars we got from the alfalfa, assuming $250 per ton, which is high. Maybe that's actually low in some cases right now, but I figured $250 per ton times that total tonnage minus that total cost. And wow. But the sulfur treatments were still the best economic net marginal return. Okay, this is just total revenue minus fertilizer cost. Doesn't figure anything else per acre. Okay, so question is, can we get by with 50%? Well, yeah, in this soil, but I think it's risky. But if you're near water, maybe, okay, maybe we can reduce our rate some. 10% difference there with the sulfur, elemental sulfur. This is just to show, this is the percent of sulfur in the total harvested forage. Normally, if you're going to do a sulfur tissue test, you do the very top third of the plant or so, the top 6 inches. This is the total plant that we harvested. And you can see with gypsum, we got to jump right away the first year because it is sulfate. It's available. Elemental sulfur takes a few months to turn to sulfate, to become available to the plant. So we really didn't expect much the first year. But then the second year, it did push it up compared to the treatments without sulfur. Okay? The recommended rate and the none here with no sulfur. I just simplified the graph a little bit. The other treatments were right around down here also. The gypsum really pushed it up, but again, we put on a lot of sulfur, way more than we needed, so it was luxury consuming. You read the literature, and it says the tissue test should be 0.25%. And these were below that. And the tissue test in the top part of that plant would normally be higher to begin with. Okay? So these would maybe be more like 0.2 in that top of the plant. But they were obviously deficient. And you could see it. You could see the pale green color. And I remember the first year I noticed it, I think it was maybe the second year or even the second full production year, I went out and I said, they forgot to spray part of the trial for leafhoppers. They had that pale green color. Well, where I noticed was where all the no sulfur treatments were randomized together in that one range. It wasn't leafhopper, it was sulfur. And then I started looking at all the other no sulfur plots and they looked the same. But they were scattered and my eye didn't catch it. But in that block where they were all together, just by the randomization in one rep, it was pale green. So definitely we did get a sulfur response. NDF, we measured neutral detergent fiber, and no clear trends in that between treatments. But for protein, there was a very consistent trend, especially in the production years. We don't have the data for 2012 yet, but where we got about 2 extra units of crude protein where we had sulfur, which makes sense because it affects nitrogen fixation. Less nitrogen in the plant. Crude protein is just percent nitrogen times 6.25. So you'd expect that. So significant little bump here of 2 percentage points in crude protein, but it's still all very good, right around 20%. Okay, so in summary, gypsum and elemental sulfur increase the sulfur content in the soil and in the harvested forage. Alfalfa yield increased 8 to 9% over the life of the stand and had a little bit of protein bump with sulfur added to the recommended rate on this soil. I was really surprised to see that. You know, that's pretty good soil out there at Western and South Charleston. So marginal returns were highest for treatments containing sulfur. Yield response to gypsum, I think, was likely due to the sulfur and not the calcium in the gypsum, because the calcium content did not differ from the tri-state recommendation without gypsum. Okay, without gypsum and with gypsum, the calcium content in the forage was the same. So we need to be aware of this increasing potential for sulfur deficiency, especially where you don't have manure. Okay, now that's not true for a lot of you, but you may have some fields that are just hay and no manure is applied. So we need to be aware of this. If you start thinking the growth is a little less than you think it should be, a little pale green color, you could run a tissue test, send that to the lab and ask for a tissue test. If it's below 0.25%, then consider putting out a test strip with sulfur. So we need to check more alfalfa fields across the state for this. Dramatically reducing our P&K rate like the 50% of the recommended or even 50% of crop removal in a low testing soil, I think is risky, especially for long term. But on a short term, you need to save some cash. Maybe you can get by with it, and it depends a lot on what your soil test is. You know, if you were a lot higher, you can get by without some in 1 year. But again, it did not pay to reduce it You know, we cut the cost tremendously, but the net return really didn't gain compared to the recommended rates. And then the next crop would end up with a lot lower soil tests, so over time that's going to catch up with you. Okay.